All right, guys. Before we get started on the lesson today, before we finish up this note sheet, are there any questions over any of the assignments? Any of the assignments so far? So, if there's no questions, the last thing we're going to look at with this note sheet is multiplication, division, and then using the graphing calculators to evaluate these functions for a given value. Now, the first one we're looking at here is multiplication. First stack next to the filing cabinet.
Right there.
Mm-hmm. So what we're going to find first is f times g of x. And then we're going to find f times g of 9. So we're going to evaluate x, this function, when x is 9. Now, this here, what we have is f times g of x. Now, this is just a shorthand abbreviation of saying that we have f of x times the function g of x. We're just multiplying those two functions together. So f times g of x is the same as saying f of x times g of x. Now for us here, the function f of x is x squared. And our function g of x is the square root of x. And we're going to be multiplying these two functions together. Now, the second one, g of x, is the square root of x. Now, if f of x was the square root of x, we could just multiply what's inside the radicals together and simplify from there. But f of x doesn't have a square root. It's just x squared. Now, we could just multiply the two together and say x squared times square root of x, but we want to make this a single term. Now, in order to be able to do that, well, we're going to have to rewrite the square root of x as a fractional exponent. So again, this is going off our equation. The nth root of a to the x is equal to a to the x over n. Now for our square root of x, is there an exponent connected with it? Well, no. So it's just 1. Because there's no exponent written inside the radical, it's just 1. And our denominator is the index of the radical, for us would be 2. So x to the 1/2 is the same as the square root of x. Any questions on this here? Well, now we can actually multiply these together, and when we multiply like bases, we add the exponents. So for us here, we'll have 2 plus 1/2. Well, luckily 2 plus 1/2. We could do this by hand, or we can do it in the calculator. Either one is fine. We just needed to leave it as a fraction, not as a decimal. Now, if we did this by hand, well, we'd have to turn 2 into a fraction with a denominator of 2, and the numerator would be 4, because 4 divided by 2 is 2, so 4/2. And 4/2 plus 1/2 is 5/2. So our f times g of x is x to the 5/2. Yes. Right, to go and add these together, since 2, highlighter, since the 2 here doesn't have a denominator that's the same as our 1/2, we have to make it so. So turn it into 4/2, which is the same as 2. And then we can add them together. We could have also just done this in the calculator too, plus 1/2, hit enter, and gotten it that way. The graphing calculators may turn it into a decimal, which would have been 2.5. But if we go math, fraction, enter, it'll convert it back over. Also, the TI-30XS, the yellow calculators can do that a little bit quicker. But either way, this here is our answer. Okay. Now, we need to evaluate this when x is 9. So we're just plugging 9 in for x. We're taking 9 to the 5/2. And again, so for this here, 9 to the 5/2, that's all numbers, yes? So we could plug this into the calculator and let it do it for us. Now, if we're doing this by hand, the 2 in the denominator is representing a square root, yes? What's the square root of 9? So we're really saying that I have 3 to the 5th. Now, 3 to the 4th is 81. If we multiply that by 3, I think we get 273, 243. Yes. I'm thinking of 9. Yeah, I multiplied the 3 by 9, not by 8, and got 27. So this is our f times g of 9, if we evaluated it. But that's it. That's all we have to do for these here. Questions on these here? Not too bad. Let f of x be x cubed and g of x be the square root of x. So we want to find f times g of x and then evaluate the product when x is equal to 4. Well, f times g of x is the same as saying f of x times g of x. We're just multiplying those two functions together. Now, we can go on and replace f of x with x cubed and g of x with the square root of x. Now, for us to be able to multiply these, again, since we want one main term, and again, the homework's going to be the same way, we need to convert the square root of x into a fractional exponent, which would be x to the 1/2. Now we can go on and add the exponents. So we're doing 3 plus 1/2. Well, to get the denominators to be the same, we need them both to be 2, 6, which gives us 7/2. So this is our f times g of x. And if we wanted to talk about the domain for this here, which we haven't really talked about at all, is going to be all the values of x greater than or equal to 0. Because part of this is what? The square root of x, yes? What numbers can we not plug into a square root and get real numbers out? Well, we can do 0, because square root of 0 is 0, yes? So square root of 1 is 1, yes? There are certain numbers we can't plug in. Because we can do 1/2. Square root of 1/2 actually works out to be 1/4. But, or not 1/4, because square root of 1/4 is 1/2. Negatives. Because I can't take square root of -4. Because we can find it, it ends up being 2i. So we can't take the square root of a negative number and get real numbers back out. Because if I'm wanting to graph it, well, on the real graph or the real xy coordinate plane, we can't get anything out because we can't take square root of a negative number and get a real number out. So the domain is restricted to all the numbers that are greater than or equal to 0. All the numbers that would come out of the function. All right, well, let's look at the last part of this. Because we're trying to find f times g of 4. We're just plugging 4 in. Now we can plug this into the calculator and say 4 to the 7/2 and hit enter and get now again, the half, the 2 in the denominator is really saying we're taking the square root of 4, which is 2 to the 7th, which is 128. Questions on this here? F divided by g of x and state the domain. So again, the domain for these here with division, we can't have a negative inside the radical. 3/4 is technically a radical. We can't have it be negative. But also, whatever values are going to make that 0 don't work either. We can't have 0 in the denominator of a fraction. Now, the first thing we're going to find is f divided by g of x. F divided by g of x, which is just a simplified way of saying f of x divided by g of x. And once we find this, we're going to find f divided by g of 16. Now looking at this here, they gave us f of x. F of x is 6x. And they gave us g of x as well, x to the 3/4. Now we have like terms on top and bottom, so we'll need to simplify this to a single variable. And whenever we divide like bases, our x and x to the 3/4, we subtract the exponents. Now looking at this here, is the exponent bigger on top or bottom? Top. What is the exponent in the numerator? 1, because we have x to the 1st, yes? The exponent on bottom for x, I should have specified x, is 3/4. 1 is going to be greater than 3/4, yes? So that means the variable is actually going to stay in the top. So what we can say is that we have 6x to the 1 minus 3/4. It would do that. One more time. Now, normally we would rewrite 1 so that the denominators are the same as 3/4. But it's 1/4. Because luckily, since it's 1, we're looking how many more fourths do I need to get to the next whole number, which is 1. So it's just 1/4. Now this is also helpful because, again, 3/4 is a radical. Even though there's a 3 in top, it's really saying we're taking the 4th root of x. We can't have radicals in the bottom of a fraction. So we really needed this to move out of the denominator anyways for it to be in simplified form. But this here is our f divided by g of x. Now the domain for this here, and again on the homework, I'm not going to want or specify that you do the domain and range, or especially the domain. It may ask for it, but again, I'm not going to require you to do that. Here the domain would be greater than or equal to, or just actually greater than 0. Because it did have a division, we were dividing. So any of the values for g that would make it 0, make g of x 0, make what we're dividing by 0, cannot be included. So it would just be greater than 0. So this here we would have 6 times (16) to the, which is 12. Because 16 to the 1/4 is just saying we're taking the 4th root of 16. What times itself 4 times 16? 2. 6 times 2 gives us 12. Questions on this here? All right, let's look at one more division problem before we move on to the next part. Let f of x be 4x and let g of x be x to the 2/3. Find f divided by g of x, and then evaluate when x is equal to 17, or not 17, 27. Well, when we replace f of x and g of x, we would have 4x over x to the 2/3. Yep. Now at this point here, we can subtract the numerators, because whenever we have like bases, we subtract the numerators. Or not the numerators, we subtract the exponents. The numerator has a bigger value. Now, we could rewrite this as 4 times x to the 1 minus 2/3. But what is 1 minus 2/3? So we could say that this is 4x to the 1/3. And that's it, because if we know what it's going to be, we don't have to write out 1 minus 2/3. And the last part of this is just solving this for, evaluating this for 27, which is 12. Because 27 to the 1/3 is the same as saying the cubed root of 27, trying to find out what times itself 3 times is 27, which is incidentally 3, and 4 times 3 is 12. Questions on any of this here? Any? For this here, the domain? Yes. The domain for this here would be all the values greater than 0. And we wouldn't necessarily include 0 because of the fact that it is a division problem. The final function for x to the 1/3 does work with 0, but we still need to take into account that we were dividing it by g of x. So any value for the function g of x that doesn't work isn't going to work for the overall function, or is going to make it 0. It's a little weird how that works, especially with rational functions. We never went into it or got too involved in that. but any of the restrictions for the domain of either one of these functions when we divide have to be included in the final domain. Any other questions on this here? I feel like for the most part y'all are comfortable with addition, subtraction, multiplication, and division dealing with these here, yes? So, and instead of boring y'all with more of these here, what I want to move on is to the last part. So we're skipping 2 and looking at performing function operations using technology. So we're wanting to evaluate f plus g of x, f minus g of x, f times g of x, and f divided by g of x when x is equal to 2. So we're not actually finding what the function is in terms of x, we're just trying to solve it when x is 2. So we have the square root of x and the square root of 9 minus x squared. Now when we do this here, we're going to use essentially the graphing utility. So to do this, we're going to hit y equals. And we're going to type second square root of x into the first one, because f of x was the square root of x. And for g of x, we're going to plug it into y2, which was our second square root. I believe it was 9 minus x squared, yes? So we have this here. Was everybody able to get these typed in for y1 and y2? Yes? We can go on and hit enter. Now, normally when we did this, we would hit graph next and kind of use the graph to figure this out. And we get these here. The one in red is the domain for the square root of 9 minus x squared. And its actual domain is restricted between -3 and 3. We can only have values between those 2 points. And the other function is going to be greater than or equal to 0. Now, we aren't going to be using the graph itself to evaluate these points. Go on and hit second quit to go back to the home screen. I'll clear that out. We can actually use the functions y1 and y2. Now to get there, we're going to hit alpha, trace, alpha F4. And it should give you this menu. You all have this here. Now we'll hit enter so it says y1. What this is doing and what this is telling the calculator is we're going to be using that function that we've inputted into y1, that first equation. Now, if I hit parentheses 2, close parentheses, put 2 next to it in parentheses, what that's telling the calculator is that I want you to take that function and plug 2 into it. I want you to input 2 into that function. Now, the first operation that we had was f plus g of x, yes? And we want to evaluate it when x is 2. Well, we have half of it. Now we just need to add g of x, our y2, in. And to do that, we'll do alpha, trace, but this time we'll go down to y2 and hit enter, and do parentheses 2, close parentheses. So what we're telling the calculator is I want you to take the first function, well, f of x, and input 2 into it. And add to it our function g of x and input 2 in for it. Hit enter. And that's it. Because if you hit enter, that's the value of those 2 there. Ah, we're missing a function. So we'll do square root of x in the first. squared of 9 minus x squared. And that's it. Yeah, you just didn't have the second function put in, so it wasn't wanting to do it. Now, that was just for the first part, yes, because we added the two. It also wanted us to subtract, multiply, and divide. Now, we could go through for subtraction because we're still using the same two functions and the same number, yes? What we could do is go back and alpha trace y1, parentheses 2, close parentheses, plus alpha trace, go down to y2, parentheses 2, close parentheses, and have subtraction in the middle. Or we can go up and highlight the first equation and hit enter. And it'll copy it back down. Any of the calculators will do this. And what we can do is go where it says plus and change it to minus and hit enter. So if we subtract the two, we get negative 0.8218544,151. And if we wanted to do multiplication, we can do the same thing. Go up, select it, and go over, change it from subtraction to multiplication. And we can also divide. Okay. Yep. Yeah, a lot of times, even if you hit clear, you can try going back up. It doesn't, the graphing calculators don't always actually clear everything out. It's sometimes still hiding up above. You're welcome. But that's it. That's all we have to do to use the graphing calculator to solve these. We could do 3 or more functions, but the graphing calculators will only evaluate for a value for a specific number. Because if we're just wanting to find f plus g of x with the variable still there, it won't do it. It needs a number. But we can do it with these here. Questions on this? And that's it. There aren't any that are going to be specifically for the graphing calculator, but you can still use it to track your answers, because some of these here, it is asking you to evaluate for a specific number, but we're not going to get those decimal answers. It'll be like the ones we did before, where we're getting 12 or 6, those numbers. And that's all we're doing with this here. Tomorrow is going to be composite functions, where we're putting one function into another.